So we've previously talked about the geode pattern for geo-distributed deployments, but that was more of a theoretical discussion about the pattern. What about the hands-on? Well, joining me once again today is Willie Spree as we go ahead and talk about this pattern hands-on. Listen in to find out more. Hello there, welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thank you for joining once again. We are in one of these Architecting for the Cloud one pattern at a time series. It's been a while since we've done one of these sessions, but we have a familiar face back with us again, and we'll be talking all about a cloud design pattern that we have covered previously, but we'll be going a little more hands-on today. So without further ado, we'll go ahead and we will introduce Will onto the show. Hey there, Will. How are you doing?
Hey there, how you doing?
Good, thank you. All good. Thank you for joining again. Thanks for coming back. Appreciate you being on.
No problem. Pleasure to have me. Thank you.
Excellent. So, Geode Pattern. We spoke about it quite a while ago now, it feels like. But we're going to be doing something a little different today. We're going to be looking at the problem, not from the theoretical side. I think we really delve into that quite a lot last time. So if anyone's interested, they can go and watch the previous video on that, and we'll link in the show notes. But we're going to be looking at how you could go and implement something like this. So I think sometimes we look at the theoretical side of the patterns, but now we're going to get our hands dirty. We're going to get hands-on, open the portal, and see what's behind the scenes.
Yeah, absolutely. I think sometimes it's important when you want to bring some of our design patterns to life to be able to actually take a shot under the covers, have a poke around. We'll walk through a little bit of code of a sample implementation. We'll take a look at the pieces in the portal that are being used and the services that are used to glue this stuff together. And we'll actually try and interact with a service which is implemented using the Geode pattern, which we've designed as a real world example.
Excellent. Good. So maybe as a quick high level then, the geode pattern, just to refresh people's memories. We talked about the fact, it's geographically distributed applications, but really it's geographical nodes, and that's where the name comes from, right? This geode pattern. So active, being able to go to some kind of endpoint, and no matter which endpoint you go to, you should be able to continue on with the application. So slightly different to deployment stamps, where in a deployment stamp you would have almost a separate isolated tenant or deployment. This is more of a universal service across those different geodes there. Is that fair?
I'd say that's pretty much bang on the money. Yeah.
Cool.
So you're absolutely right with the geographical node comment. That's where the term geode came from. It's not about rocks or precious gems, which actually you will see a lot of if you search for geode. But in particular, it's around the concept where your geode should be identical. So it's a deployment stamp that can service any tenant.
Excellent. So I guess with that context, and again, if anyone's interested, they can go and look at a more theoretical one, and I'll make sure it's linked on YouTube here as well. I think let's go ahead and just dive in here. So you've got a sample application that you've been using for some other pieces. So let me bring up the share here. And I can see we've got VS Code open. So Will, over to you.
We have. And what we tried to do for this particular piece of code sample, so what we're going to show today is an example of a distributed OData service. So one in which the data is located in many places, and in particular, we have an instance of this service which is running up in Western US. So you can see here I've got a cloud backend WUS, and we also have an instance which is located in Southeast Australia. So you probably can't read that on the screen share. You certainly won't be able to read it if you're listening in a podcast.
But it's in the OData context there as well.
Nice. Correct. Yeah, that's true. Yeah, you'll be able to see it there if it's larger. So, but you can see this AUSE is the geode in Australia East, and this one I've patched slightly, so you won't see this in the OData context. You can see this showing Cloud with Chris demo, which we'll come back to later on. But if you are able to squint slightly and see what's in the address bar here, you can see Cloud with Chris backend UKW, which I've specifically chosen to put this one into Wales because of Chris.
Excellent. I feel
Yeah,
very honoured.
absolutely. So deployment choices related to what you're going to present on. So, okay. And then we have this piece here, which I'll come back to again, but you'll notice here, this doesn't have an Azure websites.net address. This particular URL is an Azure front door endpoint. So azurefd.net.
Gotcha.
Yeah. And so this one will send us to any location depending on where we happen to be given at the time on which is the lowest latency.
Gotcha.
So that's
So
kind of the plump. So go on, Chris.
yeah, I was just going to kind of recap there then for folks listening in. So we've got reading into this, we've got a few deployments here. So we've got one in the US, one in Australia, one in the UK, different backends effectively. But then front door is almost going to be the thing that stitches together. Me as an end user, I don't have to remember those different entry points. I just remember, www.cloudwithchris.com. Obviously that's not what we're using here, but as an example, and then I get routed to whichever's closest to me then.
Absolutely, and that's the idea that your back end, your service front end shouldn't care. It just consumes the service, right? So it shouldn't have to know about regional deployments and deployment stamps and other things like that. Shouldn't need to know where it is. Shouldn't be able to have to use any other intermediate services. You hit a common endpoint, hence the reason for front door. Get a single front door, and the service should just figure the rest of it out for you in terms of what's being deployed. So what I'm going to quickly do at this point is I'm just going to take you through the other components which are sitting in here. We've shown front door here, but because of the deployment stack, I've dropped all of this into a single resource group.
Cool.
So we'll see a couple of app service plans here. You've got a couple of these deployments here. There's, again, one for each location. Look, so you can see Australia, Southeast, West US, and UK West. You'll see the Cosmos account, which was originally created in West US because we're using CosmosDB as a backing store. But when I drill into this later on, you'll see this is present in all three regions.
Sure.
Yeah, so we're using this as a backplane for data replication. So we should end up with all of our data available from any region and be able to write through from any region as well.
Excellent.
Okay, there's a front door endpoint here, Cloud with Chris. I actually have another one, but for a specific reason. So in a moment, you'll see a Cloud with Chris demo endpoint as well. And then we've got app service and application insights pairs for each of the geodes, which are actually hosting the app itself.
Nice.
Yeah, so for the demo, we tried to keep it nice and clean and simple. We're not doing JavaScript spars, which is the one thing you'll see if you go and look at the documented demo up on the patterns and practices / architecture center, which is a very, very nice and pretty demo, but it can actually be quite difficult to pick apart in the back end and explain what's going on. Yeah, this one we can simply demonstrate by opening up Postman. In particular, this is pointing at a single backend, but we'll come back to that. And these are just a couple of OData calls, one of which is going to read some data from a given geode, one of which is going to update that data. So it's a put call rather than a get. And the API we actually have does implement the full OData stack. So it's an ASP.NET Core Web API using the OData libraries for that service.
Gotcha.
V7, I think.
If I could just ask a favor, Will, on the Postman screen, if you can just do a control equals there, or go to the view tab and just zoom, just so we can get a better view of that one there.
Is that okay?
A bit more would be good. Yeah, that's all right. There we go. Nice. That's much better. Thank you.
A bit more possibly as well.
There you go. Cool.
Yeah. Okay, cool. Okay, so in particular, we're going to take a look at this piece. I can hide this section. Yeah, that's better. That's a lot better. Okay, so in particular, there's only two calls here just because we're going to use it as a demonstration of reading and writing for different locations, and I'll adapt that as we go in a moment. Let's go and take a look at some of the code base that you might expect to see, because an important part about geodes is we shouldn't be having to code that much for the fact that we're deploying this into geodes. Yeah, there might be a little bit around data access and data locking potentially you might have to consider if you've got multiple sources able to write the data. But in this particular design, we're just using Cosmos's routing features to route to a single writable region, which in this case will be the West US.
Gotcha.
So if we have, in fact, let me show you that as well. So for Cosmos here, You can see we've got readable regions here: West US, UK West, Australia, Southeast.
Yep.
But at the moment, there's only one writable region. So if that region fails for any reason, we'll fail it across to another instance. In order to do a fully implemented true geode pattern, you'd want all three of these to be writable.
Yeah, absolutely.
Yeah. Now, in the instance of an OData service, we don't have provision for the kind of locking and context filtering that you'd need to have in the backend service here to say what happens if two things write at the same time.
Yep.
So we've left it out for what we do today. But in a true geode, you would actually have write locations would be all three, and you'd have a lock resolution mechanism
and just
or a conflict resolution.
Yeah, and just to bring that and really pull that out for anyone listening in again, to map that back to the theory. The idea is that, if you lost 2 out of the 3 of those nodes, the application really shouldn't be impacted by that. As an overall system, it should still be able to continue. And scalability rules, etc. Yes, there may be some degradation of the system, but in theory, the system should be able to scale from that one node and take the majority of the hit there. So that's the idea behind what we're doing here.
Yeah, exactly. So in order to have that geo scale out, we have to have a common data backplane. And in this case, we're using Cosmos, which really is an ideal choice with its geo-replication features. Yeah. So if I want to bring online another geode and prep the data and seed that data into another region, all I really have to do in here is to go into this screen and I can just say, where else do I want it to be? Okay, so let's bring it across. Let's go for Central India. And that will now configure the replication setup. It will provision my endpoint into Central India and will add that data into that backplane for me. And you can see it's actually doing it right now. So see, we now have Central India here.
Nice.
It'll take a short period for that configuration to actually execute. And I don't have much data in here, right? So it should be pretty quick to do that, but we'll come back to that a little bit later on. So we've still got a readable location now, and that's the 4th region added into our backplane. We don't yet have the web app or anything else. So if we've got time, I'll come back to that and we'll add that in later on and deploy that in and create the web app, etc. for it.
Sure.
But we'll do that a little bit later on once that's gone through.
Cool.
Okay. So there's nothing particularly funky or special about our app service either. Yeah, so it is just a standard ASP.NET web API with some OData attributes decorating, and I'll just show you its startup class here. So I've commented out the authentication piece in here, but this does support Azure AD Auth, and it will allow you to authorize based on roles. So we will publish this sample. It's about to come out soon under an SAP interaction sample. So obviously SAP services tend to be very, very large.
And you know what I'm going to ask, by the way, if you could control equals a couple of times, that would be awesome, just so we can read that a little bit clearer. Sweet, that's much better. Thank you.
Get rid of the debug console out of the way as well.
There we go. Cool.
Yep, so this is actually a Net 5 API.
Nice.
So you can see from this setup here from the startup configuration, there's nothing particularly crazy, yeah? So we're just using standard configuration. So I'm not going to share my IDs and endpoint details, obviously, within here, but those are just dropped into app settings. You would in general use a key vault for those. And we're injecting in a data repository type class. In particular, this is a Cosmos one of type S, which is just a POCO. Yeah, we've written that, so if we want to swap out the backend for something else at a later date, we can do, and we can make it modular to add new features. But in particular, this is designed around Cosmos.
Gotcha.
Okay, so let's just quickly go and take a look at S-Flight. Again, nothing too crazy in here. Yeah, we've got a controller. It's just a web API with an OData routing and authorize attribute on it. Now I've turned off auth here, so that authorize attribute is going to be useless to me. But in particular, this OData routing piece enables these. So you can see we have enable query and we've got a get method. Yeah, and if I call get on the root, it will give me all of the items that come back inside the Cosmos database.
So for folks who have done implementations of .NET with kind of OData, this is just bread and butter, really, isn't it? They'll be used to this kind of thing.
Absolutely. And even if you haven't done OData, this is pretty standard in .NET Web APIs, right?
Yep.
The only bit that's any difference from what you might normally expect here is the return type look is an IEnumerable of S-Flight. So we're sending back an enumerable block of S-Flight objects, and we're not filtering them here.
Yep.
Yeah. What the OData library does, which is very, very smart, is it starts to enable the attributes that we sit into here and starts to apply link features across these within the query stream. So I can quickly show that. It's probably not massively relevant to the
but it's a nice little tip.
but it might be a nice little tip. Exactly. Yeah. So this is the UK West implementation of the geode, and if I hit this, it will go away to the CosmosDB and it will return all the records that we have. So you can see here, that's my metadata, and if you look here, an ID record. We have one ID record of type 004, and we've got one ID record of type 006.
Cool.
And that's those two there. So, but I can say, with no further code, now give me just record 6. Yeah, and that's standard as in OData. So we're saying, give me this record, and it's immediately filtered it. And what's actually happened inside the API, because we've used the OData libraries, is it's just basically done a link where clause on the key.
And that's all coming from the SDK, I guess, that you've built into your .NET code there then.
Yes, and we're just passing that down to Cosmos as an iQueryable and saying, now use the Cosmos engine to filter it.
Nice.
Yeah, so we could do that with anything we like, but the Cosmos is probably by far and away the easiest thing to build this on. So I could also do this, I believe, if I just say I want to not use OData or use the S-Flight object itself. I can say, go give me the metadata, so our services can interact with this. And what comes back is the OData metadata of the object that we've defined. So this is showing you the entity data model.
Which will effectively be then a representation of that POCO, I guess.
Absolutely. Yeah, is that. Yep. So if we look at property ref, its name is ID, it's key, which is what you'd put in that bracket. So key was ID, carrier ID, connection ID. And this data model we're using is effectively demo data that we use to interact with the SAP system. There's a standard S-Flight demo model. So if we come back and look at back in context, what you would expect to see is an object, a POCO. If it's not strictly a POCO, we are implementing an interface that has to have a property called ID. Yeah, which makes a lot of sense. So we have to have some kind of construct on it. And then we can see here, so that these fields are what we expect to define in the metadata. And if I chose to define a new one here and then deployed this out, it would immediately light up.
Gotcha.
Because we're using Cosmos with a dynamic schema, it would also query against it. There've always been null, obviously, because I haven't put any data in there. But if you did, if I added a new public cloud with Chris test, set. Yeah, and if we deployed that out now, that would come out in the schema. It would work in query, and if I added an object with that present, it would just save it and index it for me. So that's a nice way to be really, really flexible, and then the metadata is generated automatically for you anyway. So we don't have to do anything to get that metadata endpoint. It's just built when we do this.
Nice. Excellent.
Yep. So that's what that repository is. The add OData piece. So moving on from the OData part, we're doing a little bit of interest down here in the web API layer. So you can see we're turning on some defaults in terms of what we want to enable. So the filter parameter. So I should, in theory, be able to come back to here and say OData S-Flight dollar filter equals
testing your OData querying now.
I know, yeah, I've worked with this a fair bit actually. That's probably going to work actually. Yes, it's saying it's not valid, but effectively this filter clause, would be evaluated if I could get it correct.
Yeah, absolutely.
I have somewhere got a postman collection which should have these based in them as well. So
all good.
But we're not going to necessarily go through OData today. We're mapping a route. We can see this in particular. This wasn't present when I deployed it. It looked like this. Yeah, so we don't want this to be API/OData in case there are any eagle-eyed viewers and listeners out there. The version that's deployed at the moment has this, simply.
Gotcha.
So let's just run that again, just as a quick reminder. So we should now get a simple list of documents coming back that we've rendered into SFlight, shaped over OData and sent back.
Yep.
Yeah. So if I only want one, I can specify this as the ID. So let's just bring back 6. Yep, and then that's a single document coming back with the metadata again.
Nice.
Yep.
Excellent. Good.
So let's just prove that they're all equal as well.
That's a good point. Yeah. No smoke and mirrors here.
Exactly. We'll do that live as well. So there's nothing happening in here. And this is the point now where my demo crashes. No, there we go. So you can see we're filtering 6. Yep.
So it's always worrying, isn't it, when you're doing these live demos and the demo gods aren't quite happy on your side, making things take a bit longer. But there we go, all working.
Yeah, and we can see that one's just gone through from Western US as well at that point. So, and let's go in through, it's actually, because we're demoing Geode, I guess we should actually show it being accessed through the front door endpoint. Okay, and that's 006 coming in across the Geode endpoint. So I don't care where I am here. This, I know for a fact, because of the latency window, this will be being rendered from Wales to me. But if you have any viewers that happen to be watching this live or near live, I'll probably leave this up for a day or so before we tear it down anyway.
Cool.
Be able to go and hit that Azure FD.NET endpoint quickly. So just to say that's I'm currently up at the 9th. So be able to go and hit that Azure FD endpoint, and it should render dynamically from wherever nearest to where you're located. I don't know if we turn this endpoint on in our final display. Yeah, so there is possibility to display this, and we've exposed a geode endpoint I don't have configured at this point. But generally, it's a good idea and good practice with geodes to expose something which tells you which geode you're present on. And if nothing else, it's quite handy and useful for testing.
Absolutely. You think you're going in one place, but in reality, you're going halfway across the globe.
Yes, yeah, so there is a setting exposed in the coding here that I can come into, and I can say, if I want to deploy this, here, geode check. And if I deployed this environment variable geode name, then I would have expected that to have been rendered out there.
Yep.
So in this case, I haven't, but not a problem for what we're doing.
Cool.
Okay, so shall we prove out the update in one place and read from others?
Sounds like a
good plan. That kind of replication. Okay, so let's switch back to Postman. As I said, this is completely, as it happens, authenticated now, because it's just a dummy location, which we're going to tear down anyway. So what I can do here, the key premise is I can update this either from a specific geode endpoint. So I can send a request to Australia explicitly, or I can go in via the front door endpoint. So let's do both and prove that it'll actually work in the same way. So this is the Australia East endpoint. And this is a put request, which we use for an update. So I'm going to change, in this particular place, the plain type. Let's change it to a 747. And I don't know how many seats you actually have on a 747, but we'll say you've got 460 in this case. And let's say there are now 30 of them that are occupied. Okay, and we'll send that request going out. And this is just a basic OData post again. Yeah, there's nothing mad about this, or there's no smoke and mirrors or hidden data, but that will just go out to that geode, and that should now have been replicated out by Cosmos at the back end. So we can see this is item 4. Okay, so that's acknowledged back with a 200 OK. And now go back and fire this. And this is from UK West. So we can see that's replicated out there.
Nice.
And we can go and look at this then from item 4. Yeah, and we can see 747, 460. And let's do the same. We updated it in Australia, so you wouldn't have expected it to have not written to Australia, but let's check it anyway. So you can see that one there. And then we can come at this, looking at it from UK West endpoint. And you can see that one's there. And then we can go in through through the front door endpoint. And we can see we've now got 460 there as well. So they're all showing back with the same data now.
Gotcha. Excellent.
So I guess one of the other important aspects here are the kind of robustness of what we can do, and what value the front door and geo kind of replication is adding. So one of the things we could do here, for example, let's go and kill let's kill my nearest geode.
Mm-hmm.
Let's really go for it.
Poor whales.
Yeah. Yeah, we won't actually kill. So here is UK West. What should we do to the UK West geos?
Let's just stop it for now. Let's not be too adventurous. Because then we can maybe show it coming back online as well. There we go.
Okay, so it's the UK West geode is down. Now, this will take a short amount of time for the front door endpoint to actually detect this, because I've changed the probe cycle. So for about 1 minute, we'll get this. So what we'll do in a moment is we'll carry on doing something else. Mm-hmm. And then if the endpoint should detect it and basically take it out of rotation.
And I think that's an important point, maybe just for us to digress on for a sec, is when you get into these world of geo-distributed applications, you're going to be relying at some point upon something detecting a need to fail over. And I think those probe times are going to be really important when you think about things like your RTO, your RPO, and anything that you need in terms of that service availability that you're expecting to hit there.
Yeah, absolutely. So what I just want to do is I just want to take a look at that kind of scenario in a bit more depth as well here. So you can tell where I've been deploying things and around in the back end here that the health percentage has started to fail away. Yeah, so in particular, we'll start to see which one's this? That's Australia. So this is the
dark blue line.
Yeah, the UK South endpoint. And what we should see shortly is this will nosedive. Mm-hmm. Yeah, so we'll see this start to drop off quite sharply, and any kind of alerting systems that we might have would tell us that this geode had gone down, and the others, in theory, should auto scale out to cope with demand. Yeah, so in very early versions of when we used to demo some of this stuff, it was actually quite common for you to lose a region by mistake and not even notice.
Yep. Yeah, that was the fun comment we made last time, wasn't it? That actually there was something wrong with the demo when you initially showcased it, and actually, even though the one region wasn't online, the system was still able to handle everything that you threw at it, and the demo carried on as expected.
Absolutely, yeah. And we only found out the end. Demo. Okay, so just to talk about the probe piece as well, it's kind of probably worthwhile mentioning this. So you can see here our health probe is configured here to probe this /health endpoint, and it's going to be doing HTTPS and it'll be sending ahead. But this probe interval in seconds is what changes how frequently your geode will respond. Yes, if I say, actually, I want this to be probed, millimeters in here, let's say. 0, you know, on that. Like I say, can probe it every 5 seconds, but if I said actually let's probe it every 15. Now that's going to result in a marked increase in probe traffic into my back-end services, because it's going to hold them in rotation every 15 seconds.
Yes.
And that also can result in a downstream database increase in cost, because if you're actually testing inside your health endpoint to see that your database is up and working by reading a document, that's going to increase. Now, in most cases, the kind of solutions you'd build using the geode pattern, that cost increase is kind of negligible, to be totally honest. You're usually building big geo-distributed far-flung service systems, so the increase in cost is markedly offset by the decrease in failover time.
And I think, again, just to something you and I are both passionate about and we talk about a lot, but something to really pull out for folks here is the requirements are really going to drive this, regardless of whether, you know, you're a big enterprise or a small startup looking to grow your application and make it global. You might both have those requirements to build an application of this nature, but you really need to not just thinking about your profile per se.
Yeah, absolutely. So you can see our backend percentage is decreasing now, but it's only going to be probed every 200 seconds. So we won't see this sharp drop yet.
Yeah.
So let's move away from that for now, I think.
Sure.
This will eventually come back. But you can see it's down. So if I send anything to this app,
cool.
I'm just going to get a 403 back from it. So I can do that from here. It wouldn't be working, but in a location where once our probe has expired, that will just take that out of rotation. It will just continue to work.
A good question for you, though, actually, jumping into that point.
Yeah.
Yep. What is your probe looking for in terms of the HTTP status code? Because I guess the Azure website is giving a 403. Do we need to actually delete it, or is it realizing 403 is something that shouldn't be included in that rotation, so it will go ahead and...
It should be looking for a 200 OK.
Gotcha. Cool.
Yeah, I think there's actually a range. I think if it returns anything between 200 and 399.
399, yeah. That's the default for app gateway as well. Yeah.
Yeah.
Cool.
I mean, I'm not sure what we've got configuration-wise that we can play with in this edition of Front Door in the portal. So I don't think you could specify the actual request that you want to pull.
Gotcha.
Yeah, so you can't specify that in here, but we can say /health, so we can go and check what we're actually seeing returned. So that's what it'll actually be calling in the back end.
Yeah, cool.
Yeah, and if we look at that for the other items, so if we go directly to the Western US backend, it should just return a blank page.
Yep, gotcha.
Yeah, so the probe is it's working and it's coming up and running. It's just not taking effect because I've got a very long probe life cycle in here.
And it'll be after a certain amount of failed probes, right? Because it doesn't want to be too aggressive and say, right, we're going to remove you from the rotation when you don't need to, right? That's almost a false positive scenario.
Yeah, absolutely. So and that's an interesting point, actually, because if you get to the stage where something is intermittently up or down, that's where you need to make a call on how you want this surface to respond.
Yes.
So having a longer probe time kind of reduces the chance of it thrashing. Having a shorter probe time means there's a shorter period of time where it will be incorrectly reported as up.
Yep. Gotcha. And I think, again, just to reiterate, right, folks, that these types of architectures do bring a extra amount of complexity, as you can see in the types of discussions that we're having here about probe times, how long you want to fail over, and then how it goes and maps back to those non-functional requirements ultimately. So whilst we talk about these patterns and the positive aspects of them, there is that negative almost aspect of, with that does come extra complexity that you then need to go and operate with and manage and think about. So again, requirements, if you don't need to go for something as complex as this, then don't add the complexity in for complexity's sake.
Yeah, I think I agree with that. The other thing to note about that in particular is Geode is only of use to you if you want an active failover architecture.
Yes.
There's no point in doing geodes for an active passive architecture because it doesn't add anything at all. It just increases the complexity of what you're trying to do. But if you want active across 4 regions where everything is served locally with locality to your end user for speed or stamping out to get scale, then this is a great pattern to be using. And it's not that difficult to deploy, as you can see. The trick is making sure your nodes are identical and getting those time settings correct. And
I think for most people as well, the data aspect is normally where things can fall down in these geo-distributed scenarios. But as you said earlier, CosmosDB makes that a much easier story because of the replication.
Totally. It does. Okay, so
Good.
I should have changed this from 200 before we started, but we can wait for a moment and get on with something else in the background.
Good.
Is there anything else in particular you wanted us to call out or go through?
I'm just trying to think. Maybe it's worth us just thinking about some of the maybe more operational aspects again here, given we're on that topic. So, here right now you've got things like app services, you've got CosmosDB, you've got App Insights, all great resources. But something like app service, for example, you've almost got a fixed cost of I've got this many instances per region.
Mhm.
I've got this many regions, so here's a multiplication factor of how much that's going to cost me. But I think something we alluded to last time as well is that actually a serverless architecture in this geode-based approach could actually be quite an elegant pattern because you get the balance
Mm.
of the distributed nature, the potential scalability, the speed, and whatnot that we've mentioned here already. But then the benefit of if a region is being hit, for example, because your users are being routed there, you're going to see the costs go there, and your other regions will almost be colder from a cost perspective because they're
Yeah.
not actually being routed there. So that's maybe a good point for us to call out here.
So serverless works really well in this pattern, and in fact, it's what we originally put the pattern together for, was building out distributed architectures on serverless platforms. If you constructed this instead of it being a web API, just a series of HTTP bound functions, yeah, that were being piped from different backends in front door, as we've got here. You can put Appim in the middle of it. You can do all sorts of other combinations if you want to, but in particular, let's just focus on the architecture we've got here that we'd replace out. You can have, obviously, front door by default is serverlessly built. Yeah, so as you push more volume through it and you push more WAF usage through it, your cost will balance out and will increase at a consistent rate per request effectively. So you can have predictable cost based on load. You don't have any of these steps in your cost where you're trying to guess how many resources you can process or how many things you can process per instance of something.
Yeah.
Yeah. The front door is based on usage. Obviously, Azure functions in consumption mode are also based on usage. So if you can run that way, then you can have a series of backends which are deployed out. And if we'd assume if these 3 geodes were deployed in Azure Functions, I wouldn't have an instance hosting cost if I was running consumption mode.
Yeah.
So you can work on the basis that it doesn't matter which geode I hit. If the cost for all the geodes are identical, it makes no difference which one I hit apart from network latency. So if my UK West instance is no longer there, or actually I decide to scale it to 10 geodes, yeah, the only increase in theory in your cost should be the probes. Yeah,
And the data
so you do.
backend, I guess, as well.
Well, that depends because we now have a serverless tier for Cosmos as well.
True.
Yeah, so you will be storing the data multiple times, so there will be a storage cost increase. Yeah, if you have more geode backends. So if we had 10 backends, you're going to store that data 10 times, but your request units are going to be what you originally had divided by 10.
Yeah.
Yeah, so if you've got 4,000 units deployed to support 4 geodes and you push it to 40 geodes, you only need 400 units each. Yeah, in a serverless calculation. So, and that's a really nice way to be able to architect and design and build solutions on serverless because it allows you to use, in particular, Azure, but actually all cloud platforms, but allowing you the global reach and scale of these services to get performance and to get data locality, to move your data nearer to the end user and move the compute nearer to the end user as well.
Yep. No, very, very powerful, flexible pattern. Big serverless fan. And I think those two patterns combined, very elegant. Very elegant. Excellent.
Okay. Anything else? I think we've probably been going a while now. Is there anything else we want to go through around the pattern or around this implementation?
No, I don't think so. I don't know. Did we want to try that endpoint one more time, or are we gonna see how that one goes?
We certainly can do, yeah.
Let's see. Moment of truth.
Which one was it? Was this one?
Yeah.
Has it been 600 seconds?
There
it has
we go.
been. Look. So you can see now this is the Azure FD endpoint, and this time, and this is handy because there is one more thing I actually need to show you, and I'd forgotten about it.
There we go.
So you can see here, I'm not overwriting on the instances for Western US or for Australia, the OData context. Yeah, so this has actually been sent, this request now to Western US. Yeah, and I've not overridden this anywhere. It just has happened to pick it up. So just to prove that point, to make sure we're not smoke and mirrors in here. And then if we look in metrics, we should see that success, the probe success should have dropped. Because this is an average, it won't have dropped away to 0. If I left it for long enough, this will nosedive down to the bottom of the graph. But you can see here we've detected it now, look, and we've taken it offline.
Nice.
Okay.
Excellent.
So you can see that happening. Equally, if I start this back up, the geode will just come back online and it will be included in rotation as soon as the probe picks it back up. So I'm not going to do that right now, but we could do that.
Which should, in theory, be quicker than detecting it's gone as well.
Well, I've changed the probe time as well, haven't I? So if that will currently be rolling out across the CDN network at the moment, but I guess we can restart it and see. By the time I've showed you the other thing I was going to show you, it might be back up then. So we should see that then change back. So let's start this back up again, actually. Okay, so the one last thing I wanted to show you is actually a specific caveat that we found around geode, and it's around the concept that everything has to be identical. Yeah, and not all services are capable of actually serving content as if they're a node in a geode out the box. Some of them have a couple of quirks, things like location redirection headers. So you have to be very careful about what you're serving, because effectively front door is working as a reverse proxy here over HTTP. So as soon as you enable authentication, if you were serving a SPA in this way, so or an application rather than just a back-end API, then you're going to start seeing users get redirected to log in. And where they get redirected back to, you have to make a call on whether you want them to go back to the same geode or not, or whether you want them to go to a direct instance. So if we just bring that to life in context here, where I haven't overridden this, this is generated off the root instance of the website. So the HTTPS binding in particular for Azure website serves as the root for OData. So this is a nice kind of thing we can actually use to explain this. If this was authorization, I'd go onto the authorization page to go to log in. I'd go and get a token from somewhere, and then I'd probably be redirected to a fragment that has the original URL. Yeah, so if this was a web page, I would go to this endpoint, and after the authentication dance completes, I'd get sent back here. Yeah, because the website is not aware it's acting as part of a geode network. And that's a key gotcha. It's one thing to think about. It can be quite important. We've implemented something in here which is not necessarily best practice, but in ASP.NET OData, we don't really see another way to do it in the latest libraries. So what we're doing here is a request writer middleware. Yep, and if you look here, we've just got this application builder, use request rewriter, and all this is doing is it's injecting itself into the request pipeline for ASP.NET, and it's effectively doing a find and replace on any piece of data that comes through. So you can see we've got an inheritor of a memory stream here, which is a text replace stream, and when we construct this, we're saying, give me a list of strings, which are things we might want to search for, and give me something that I want to replace it as an output. Yeah, and we'll literally mount through those, perform the find and replace, and then write back to another stream.
Gotcha.
Result of that is that in flight, if you configure this with Cloud with Chris backend -UK UKW, and when you host that backend, originally when I showed you this, if I hit back, I think I'll see the original one. Yes, I do. So if I hit back, look, the original call that came in when we were on the UK geode had been rewritten to this endpoint.
Gotcha.
Yeah, so any relative links, any headers that come across, we can do as well. You can normally do headers on the CDN, actually, but you're going to be thinking about some kind of middleware layer. And the key part is it's really important to remember how your URLs are formed and where they should go.
Yeah, I think anything where you need to start doing rewrite rules to make sure your authentication works starts getting into complicated territory, then it could be a session in its own right, I think.
Yeah. Well, I think there's the important thing as well, right? So if you're going to do a JavaScript SPA, for example, yeah, then you're going to implement your own
authentication
front-end code to implement. Yeah. When you do that, make sure that's part of the geode. Yeah, so when you access that through the front door instance as well. So what we're not doing in this context, because we don't have a front end here, so there's no front end to this, we're consuming this with downstream systems, but you'd have an additional back end showing up here for a static page or a static web app. I'm moving my mouse in a circle, I haven't actually clicked in. So you'd have another back end pool here.
Yeah, gotcha.
Yeah, you'd have a front end back end pool, so to speak, and then a routing rule here that says anything going to the root goes to this pool, anything going to /OData goes to this one, and then any cores that you'll see and all that is all gone. It's out of play.
It's almost a central service then, isn't it?
Yeah, exactly. That's the idea. They all act in tandem. They're all aware that they're part of the same service. Gotcha. Yeah. Where this becomes interesting is if you try and do this using something like ASP.NET's middleware or App Service EasyAuth, which you can do it, but you need to start doing it custom SSL and custom domain hosting. And it's not that difficult to do, but you just need to be aware that you need to consider it.
Yeah, absolutely. Excellent, good stuff. And let's revisit it then. Let's see if that app is showing back in the pool for us.
So let's make sure it's actually come up first. Okay, so that 404 is correct because we don't have anything on the root.
Nice.
Okay, so we're at the store is actually up. So let's see. Okay, and you can see the URL has changed. So the instance at UK has this redirector enabled on it, and only this instance. So you can see that's actually come in. So I think if we go and look at the metrics now, we'll see that backend health percentage has gone back up again. That's backend request count, not metrics. So backend health percentage. Yeah, you can see it dipped and now it's
nice.
Up. If we split this by backend.
Yeah.
Yeah.
It's a big time.
Right down actually.
Yeah. Nice.
So there's a slight time lag on the metrics here as well. But
excellent.
You can see it's gone down and back up there. So we don't have anything coming in from here, but you can see that peak there. Is it going back up?
Oh, gotcha.
So that shows you how you can take things offline. If there is any further appetite to do anything more, let me know. But I think we probably got to the end of what we wanted to do today.
Excellent. Awesome. No, I think really great session there, Will. I think it complements nicely what we did previously on the theory side of it all. Just a big thank you for coming on and talking about it all. Appreciate it.
As always, thank you for having me.
Thanks, Will. So there we go, folks. We have talked all about the geode pattern, moving away from the theoretical side of things, looking more at the practical, hands-on side of it. So looking at an example OData application there, taking that across different regions, Australia, the US, the UK, and then going ahead, taking some nodes off and showing how the system overall can keep going. As an end user, we're not really impacted. And of course, there's some things to consider there with probes, backends, and also some considerations around authentication, etc., and rewriting. So hopefully that's been useful. You know what to do. If you've liked the content, please go ahead, hit the like button, hit subscribe, and hit the notification bell so you know as soon as there is new content. And of course, you might not be listening to this on YouTube. You might be listening to Apple Podcasts, Google Podcasts, Spotify, or cloudwithchris.com, where of course on the website you can listen to the recording as well as read the transcript all at the same time. But if you don't want to do that, you can also read blogs on cloudwithchris.com. So there's plenty of content to go and keep you occupied and keep you busy. So with that, thank you all for watching. Stay safe, stay healthy, and until the next episode, bye for now.